Okay, so for number one, I hope you looked back at your notes from the first day. To draw the 45-45 triangle, we've got a 1, 1, root 2 sides. And for 30, 60, 90, across from the 30 is 1, across from the 90 is 2, and across from the 60 is root 3. For these ratios, sine of 30 is opposite over hypotenuse. Excuse me. Cosine of 30 is adjacent over hypotenuse. Tangent of 30 is opposite over adjacent. This one we have to fix. I hope you rationalized your denominator. And we get root 3 over 3. Now for sine of 45, I'm going to go to this triangle and go opposite over adjacent. Oh, I got to rationalize that denominator. So now cosine of 45, that's also 1 over root 2. And we've already rationalized that. We know that's equal to root 2 over 2. Tangent of 45 is opposite over adjacent. And now for 60, sine is opposite over adjacent. I said that wrong. Opposite over hypotenuse, sorry. Opposite over hypotenuse. Cosine and tangent, opposite over adjacent. So down here, number 3, if you did this already because you printed your notes, great. If not, I want you to redraw the 2 special triangles, but label your angles with radian measures. So we'll pause here for a minute for you to do that. So if you look back at your homework answers from the other day, you'll see that 45 degrees is pi over 4. So both of those answers are pi over 4. 30 degrees is pi over 6 radians. And 60 degrees is pi over 3 radians. Okay, our announcements. This is not correct. Here we go. We have the check-in time this afternoon, Thursday. I will be back in school for that. So if you need my help, come this afternoon. You have the day 3 homework due Sunday. And for you all, your last quiz grade is due Sunday. I'm sorry, your last quiz, which is due Sunday. I will rate it. It is called, hang on, let me get that. Quiz 8. So take out your agenda books, write that down. And then today you're going to title your notes, standard position, quadrantal angles, and coterminal angles. These are 3 very specific vocabulary terms that we are going to use through our trigonometry unit. We will pause here for you to write down the angles and standard position with this picture. So an angle standard position is when you have the initial ray on the positive x-axis and you rotate counterclockwise for a positive angle. Now, we could rotate, so let's say this is theta. We can rotate clockwise this way. That would be a negative angle. The terminal ray is the ending side. So this example, this theta is 130 degrees. So let's sketch some. We're going to always start with a little coordinate plane. Initial ray is on the positive x-axis. 40 degrees is acute, so we'll put that in this first quadrant. Now 90 degrees, here's our initial ray again, is on the positive y-axis because each quadrant is 90 degrees. Always draw that initial ray. And now, so for pi radians, I know pi radians is 180 degrees. So that's going to be a straight line like this, where that angle there, this is pi. (225), we got our initial ray, 90, 180. So 270 would be all the way down here, so that's not quite that far. So this large angle like this is 225 degrees. Oh, finally a negative angle. Here's our initial ray. Negative 30 just means go clockwise 30 degrees. So this angle is negative 30. Okay, I want you to try these 5 examples. You draw these 5 angles. We'll pause the video for you to do that. Okay, 100 degrees, initial ray, terminal ray. There's my 100. So negative 100, initial ray, negative 90, and here, this is negative 100 degrees. Negative 300, we're gonna go all the way around this way, it's negative 300. Initial ray, so 180 is gonna be the same picture as this pi. And then 310, that's gonna be over here where this whole angle is the 310 degrees. Okay, so then the next topic is quadrantal angles. We'll pause here for you to write down what a quadrantal angle is. So a quadrantal angle is an angle in standard position whose terminal side is on the X or Y axis. It's on the quadrant line. So for this first one, it's saying label the positive quadrantal angles. So we start over here. This is our initial ray at 0 degrees. The next quadrantal up here at the y-axis is 90. Then we have 180, 270, and back around to 360. So now we're going to do that in radians. We've got 0 pi radians, pi over 2 radians, pi. So you can think of this, we know that 180 is pi, so 90 is half of that. So when we go to 270, now we've gone 1.5 quadrants, so that's 3 pi over 2. And then all the way around 360, oops, is 2 pi. These quadrantal angles in radians and degrees we're going to use all the time. Now going negative, we still start here at 0 degrees, but going in the clockwise direction, here's negative 90, negative 180, negative 270, negative 360, 0 pi. Over here would be negative pi. So then this is halfway, negative pi over 2. And then this is negative 3 pi over 2. And all the way around, negative 2 pi. Okay, and the last topic is coterminal angles. So add this definition to your notes. Two angles are coterminal if they're drawn in standard position and both have their terminal rays in the same location. So for example here, we've got this angle here, 75 degrees. The initial ray on the positive x-axis, here's the terminal ray. This 75 degrees is coterminal with 435 degrees. You can see they do this little swoop. We're going to go all the way around a full circle and then add the 75 again. Another way to think of coterminal angles, here we've got an angle of 51 degrees. That's coterminal if we go clockwise with negative 309 degrees. Both of these angles have the same terminal ray. So take a second and jot down, how can we find coterminal angles? What happened in this first picture or in this second picture? So hopefully what you noticed is you saw the angle, we can either add 360, that's this first one, or you can take the given angle and subtract 360. That's this picture to find the negative angle. How would that change if we were in radians? Instead of the 360 degrees, what would you add or subtract? If you said 2 pi, that's correct. We would add or subtract 2 pi since that is the radian measure of a full rotation of 360 degrees. So we're going to practice finding one positive and one negative coterminal angle. We've got A, 50 degrees. So we'll take our 50 and add 360. We take our 50 and take away 360. I like subtracting vertically. This is easier. That's negative 310. So 50 degrees, 410 degrees, negative 310 degrees are all coterminal. The terminal ray all ends in the same location. So then for 230, let me color code it with my degrees here. All right, so we got 230 plus 360, 230 minus 360. Okay, so now with radians, we have pi over 2. I'm going to add 2 pi, which is a full rotation. I'm going to subtract 2 pi. We need a common denominator. I have a fraction and a non-fraction. So since the denominator is 2, and multiply the numerator and denominator. So this gives us pi over 2 plus 4 pi over 2. And we get a coterminal angle of 5 pi over 2. Going to work the same way here. Oops, step is going to be subtraction. Negative 3 pi over 2. All right, let's try 3 more. We'll pause the video here. You try these 3 problems. So negative 60 plus 360. Negative 60 minus 360. And now in radians. We need our common denominator. This is by 3. So we get 4 pi over 3 plus 6 pi over 3. That's negative 2 pi over 3. So we get 10 pi over 3 and negative 2 pi over 3. Now, last but not least, for 3 pi over 4, since I know I'm going to add and subtract 2 pi, I'm going to write 2 as something divided by 4. So instead of doing 2 pi and then finding the common denominator, I'm going to go straight to 8 pi over 4, because 8 over 4 is 2. The answers for F are 11 pi over 4 and negative 5 pi over 4. Okay, so now is homework time. It's 2 pages. Use whatever time is left in class to pull up these in the module and work on the 2 pages and submit that through the assignment.